Okay, so now we're going to do the same thing for test. So we don't have the false negative, false positive, true negative, true positive for test. So we have to really go and look at the exported data. Okay, so now we have the test set that has data in it. Okay, and let's export it. And we want predicted cat med v equal to 1. Okay, so copy that. So that would be our y hat. Just only the data. So that's our prediction for k equal to 16, and the actuals are, this is the from cat v. Okay, so that's our original value. Okay, so from cat v is our y. Okay. Now we do the same thing with k equal to 8. Okay, test, browse, export to Excel. Okay, so predicted med v equal to 1 is what we need. Okay, so that's the y hat for k equal to 8. Then we can set up this table to figure out the actual cases. Okay, so how do we do that? So we have done this previously. All right. So count ifs, right? Count ifs. Okay, so there are two conditions here. We want to count the ones in the y. Okay. The second condition is the y hat. Okay. The y hat must be greater than or equal to the threshold value, right? So that second condition means it will go through y hat and see whether the propensity is greater than or equal to 0.5. And among those cases, it will look at the y column and count how many are ones. So actual is 1, predicted is also 1 based on this cutoff. Okay. Then how many, You can use count, or you can also use sum because these are 0 and 1. So if you want to do count if, it is how many actual y's are there. So that column, comma 1. Right? So that is how many ones there are, and then simply count that column will give you how many cases there are. Okay? So then this will be that, and how many predicted y hat, so the range will be y hat, and the condition is greater than or equal to ampersand okay, then that minus that will be that, and then that minus that. What's that? Oh, this is test. This is not. This is validation. This is test. So it's a different data set. And it is pretty close because it's 30%, 30%. So that's why it's really close. Alright, so I'm going to copy these and make the changes. Okay, so that would be the same as that. That would be the same as that. Okay. So here it should be, instead of I, it should be J. And 35. So here again, I don't know where. Wait. This edit and copy, so that way it'll be easier, and all I have to do is just put that into J. Okay. All right. So then we construct these, that plus that. That. Like that. Okay, and the rest of it would follow this. What I'm going to do now is to just show you what that final result is, so you don't have to keep doing it again and again. So here it is slightly different. Well, no, yes, the numbers would be slightly different. So if you compare, you see that even in the test data set, k equal to 16 gives you uniformly better result. Yeah, well, not uniformly, because misclassification rate is good. Sensitivity k equal to 8 is better because it is capturing the pattern, the pattern in the nearest observations. Okay. Specificity k equal to 16 is better, and the false positive rate and false negative rate. Okay, false positive rate k equal to 16 is better, k equal to 6 is better for false negative rate. So it's between 8 and 16. It's kind of a toss-up. Okay. But if you want to try several more k's, then you have to build more k's here and then connect them up with a model comparison and compare.